Good morning, guys. Am I audible to all of you?
Good morning, sir.
Okay, very good morning. So today we are going to discuss one of the important, you can say important concept. If you are working as a .NET developer, it is not related to .NET developer. If you are working as a developer, right? If you are a developing project or you are planning to architect the project, right? Then this session is for you. You should know how you can design the good software. What is the problem if you are not following the design principle? So everything we are going to discuss. So today's session is all about solid design principle. So first of all, guys, my screen is visible to all of you, right?
Yes,
Yes,
sir.
sir. Visible, sir.
Okay. So let us start today's session. So before proceeding further, I just want to know anybody having any idea what is this early design principle? Why we need to follow or why we need to implement this design principle? If we are implementing, what are the advantages we are getting? If we are not implementing, then what are the problems we are facing? Anybody having any idea?
No, sir.
Anyone else?
No, sir. I don't have.
Okay. See, basically, if you want to develop good software, right, then you need to follow solid design principle. So, as a software developer, while developing the application in our day-to-day programming, we are facing some problems. We are facing some difficulty. We are facing problem in order to understand the code. We are facing problem for the flexible, right? Flexible in the sense it is very difficult for us to maintain the code. Some existing code is there. We need to touch those existing code, right? Again, it is very difficult to maintain the application code. As we are touching the existing code again and again for the changes, for the bug request, right? For the new addition, for the enhancement. So as a developer, we are facing some problem. Why we are facing problem? So the main reason for facing the problem is tight coupling between the software component. So what is the meaning of a tight coupling between software component? For example, you are designing two classes, right? One class is creating an instance of another class and calling the method. That means in that case, one class knows about the other class. So in that case, if you are going to change the implementation, for example, okay, let me show you, right? For example, this is one layer, right? You can say this is employee class, right? Employee class creating an instance of employee data access. So once he create an instance, then he can consume the method, right? So let's say employee data access class instance, and then using that instance, he is calling the get employee method. He is calling the get employee method. That in this case, this employee class is completely depend on this employee data access class. And as it is a class and it is another class, that means there is a tight coupling between these two classes. So today you are using this employee data access class, which is interacting with your SQL Server database, right? SQL Server database. Now, what is your requirement? Your requirement, you need to perform some kind of a unit testing. And for unit testing purpose, you don't want to use this employee data access class. You need to use a different class. What is that a different class? The different class is employee, okay, data access, you can say demo, right? And this employee data access demo class is also having this get employee method, right? The structure is going to be same. But the thing is that in this case, it is connecting with your SQL Server database. But in this case, you can consider it's a hard-coded data, right? Hard-coded data. So if you are changing, so this is your one layer. So employee data access means it's a one layer, and this is your another layer. So if you or you can say it's a class. If you are changing this class from employee data access class to employee data access demo class, then you need to while you in previously you are creating an instance of this class. Now, do you think that using this instance you can call this employee get employee method? No, you cannot call. Why? Because if you are using this instance, then it will call the employee data access class, but it will not call the employee get employee data access class. So if you want to call this, then again you need to create an instance of employee data access demo class. That means what? Now that means while you are changing your if you are changing, so let's consider that this is business layer and this is data access layer. Let's consider. So in that case, the business layer is tightly coupled with data access layer. What it means? It means if you are changing the data access layer code, then you need to change the business logic layer code. And this is because both are tightly coupled. Instead of that, what I can say, I'm having some I employee data access class, right? I employee data access class. This I employee data access class having something called get employee method. So this is an interface, not a class. It's an either an interface or an abstract class interface. Now this class inherit from this class, right? Now this class is also inherited from this class. Now here I'm providing some kind of a factory method, right? I'm providing some kind of a factory method which is going to return an instance of either this class or this class. So if I'm not using this IEmployee data access class, rather I'm using some kind of a mechanism where that class is going to return me an instance of the of any type in the sense employee data access type or employee data access demo type, then using that type I can call the method. Now if you want to call this method, then you need to change in the DL in the data access layer, not in the business layer. So if this is not clear at the moment, don't worry, we'll see these things practical. Practical means I just trying to explain you what is tight coupling. Tight coupling means you are dealing with the classes. How you can overcome this? You can overcome this by using interface and inheritance concept. Practically, we will see these things. So basically, the major problem with most of the software problem is tightly coupled. So what is a tight coupled code means? As a developer, we started developing application by directly creating classes and making inheritance and making object of those classes directly. Instead of that, we need to make the components, or we need to make the classes as soon as possible as loosely coupled. How you can do this? That we will see practically, right? So solid design principle are the design principle that helps us to solve most of the software design problems. This design principle provides us with multiple ways to remove tightly coupled code between the software component. Whenever I'm saying tightly coupled code means one class doesn't know anything about the other class. One class is not we are not creating an instance of another class, but we are getting the instance of that class by some different way. How we are getting the different way? We can get them. We can get that. We can remove that tightly coupled. We will make the software component loosely coupled in many different ways, and those ways we are going to discuss today's session. And if we are following this, if we are making our application code loosely coupled, then that will be more understandable, more flexible, and more maintainable. So you will understand your application code very easily. You can change the code up as easy as possible, right? And if you are understanding the code and if you are able to change the code without affecting other existing code, that means what? That means your application is more maintainable. So basically, in order to achieve these three things, we need to use solid design principle. Then why do we need to learn solid design principle, right? As a developer, suppose you are a developer, I am a developer, everybody is one developer. All the developers don't have the same experience. Few developers having 5 year experience, few developer having 10 years experience, right? Few developers having, please unmute. Pratik, please mute. Mute, right? So as a developer, based on our experience, if I'm having 1 year of experience, then I can develop the application as per my experience. If you are having 5 year of experience, then you might be design the application as per your experience. And if you are having 15 year experience, then definitely the application architecture is going to be different. That means as a developer, if someone give one task to us, or if we want to start developing an application, then we will develop the application definitely, but that is based on our experience and knowledge. But once we develop the application, don't think that the application is done. Over the time, the application might arise some bugs, right? Then if some bugs arises, then we need to alter the application design, right? For every change required. That means, see, once you develop the application, don't think that application is completed and application is over, our task is done. So in real time, if you are developing one application, then definitely you are getting some ticket for some bugs, right? Some bug might 100% some bugs arise in the production, right? Once the bug arise, right, that bug might be identified by your QA team or by identified by your UAT team, or might be identified the client, right? So definitely some bugs will arise. Then once the bug is arise, then you have to do the changes. Apart from bugs, other things are also there. Some existing feature which client in that existing feature the client want to do some modification, or even as you know, once you develop a project as the application, we are developing a project means that project is for some organization or for some business. As the organization grows, as the business grows, then then the client for who we are developing the application, he might want to add some new features, he might want to update some existing feature. Then for those new feature, for those existing feature, or for those bugs, we need to change the application. If we are not designing the application by understanding, if we are not designing the application correctly, then what will, then in that case, we might face some problem. In order to do a simple task, a full working knowledge of the system is required. And in that case, we cannot blame the box, we cannot blame the change request, we cannot blame that this is a new feature, I'm not going to do, this is a bug, I'm not going to touch, or this is one existing feature of the, or you want to update this existing feature, I cannot do. You can't share this thing because this is the part of a business. You cannot refuse them. So who is the culprit here? What is the problem we are facing? Who is the actually, what is the culprit? Obviously, the design of the application. If we are designing the application in a better manner, so any new change request, any new feature, and updating any existing feature, any bug arises, if your application design is good enough, then you can easily handle this, right? So what are the advantages, guys? First of all, I'm discussing some of the theoretical concept, then I will come to practical, right? So advantages means your application will be more maintainable. You can test the application, right? Parallel development is also possible, right? So nowadays, maintaining the application is the biggest challenge for the industry. Why? Now, why? Because suppose today you are developing the application. If you are working professional, you might be know the developer who work for a company, he leave the company in 1 year, 2 year, or 3 year. That means the person who developed the application might not be available in the next year. Then a new developer will come in that place. And then it is a biggest challenge for that developer to understand your application code. If you are not if you are not writing the code in a proper manner, then the new person who will come to your come to the company and trying to understand the code, right? Then he will nightmare for him. Right? So guys, please once you join, please mute yourself. Okay. So that will become that means maintaining the application is the biggest challenge in the industry nowadays, right? But if you develop the application by following some design patterns, by following some design principle, then it will not make that difficult for the new developer to understand your code and add some new features, update some existing feature, right? Or identify the box, resolve the box. That will not become that difficult if you are following some design patterns and the design principle. And second advantage is testability. Testability means what? Nowadays, if you are developing one application, then writing unit testing code is is one of the mandatory things, right? What is unit testing? Unit testing means if you want to test each individual component, what you developed in your application individually, then you need to write unit test. You need to write unit test code to check whether the code what I have written is working fine or not. This is my expected output and what output I'm getting, whether the expected output is equivalent to the original output or not. If original output and expected output is same, then the unit test is passed. Yes, it is fair. So and if you are following the design patterns and design principle properly in your application, then writing unit test code is not that difficult. But again, if you are not following any principle and any design patterns, then it will become very difficult to write unit testing code. Parallel development. Parallel development means what? See, if you are writing every code within a single class means what? A single developer can work. But if your application containing 10 different classes or 10 different models, you can say, then 10 different developer can work. One developer for one class, another developer for another class, another developer for the third class, and so on. That means nowadays, for any kind of application you develop in real time, don't think that one person is going to do everything, right? So a team of people, right? A team of members are working on the same project, right? So the parallel development is also one of the important, most important key aspect nowadays. As we know, it is not possible to have the entire development team will work on the same model at the same time. So we need to design the software in such a way that different team can work on different models of the project. As a result, if different team, if different member of the team work on different model of the project, that means the productivity will be increased. If one person developing the application, then he will take 10 days. If 10 people developing the same application in 1 day, that will be completed, right? And again, what will happen? Now, one person working means he know only the working principle of the project. What is the functionality of the project? But if 10 people are working, then 10 different people will know about the work, how the project is working, right? If you are individually working, then whether you are writing the good code or a bad code, whether the architecture is the same or different, right? That will identifying is difficult. If 10 people means everybody will give their input, and whenever more than one, whenever a team of people working on the same project, and when 10 people are giving their input, definitely the project architecture is going to be a good one. So design principle and design patterns implementing in your application is more. If you are not following, then you will not manage your application code very easily, right? It's very difficult to understand your application code. But if you are following design patterns and principle, then these things you can easily achieve, right? What are the main reasons behind for most unsuccessful application, right? See, for me, there are two things. One thing is putting more functionality on a class. So as a developer, I know if right. So in my previous organization, and whenever I come, I see there is only one controller. That was a MVC application and web API application, right? Which is assigned. One controller is there, and inside that controller, every action method is written. That means what? Putting more functionality in a single class, which is very bad, right? In simple word, a lot of functionality we are putting in the class, even though they are not related to that class, right? So what we need to do, you need to write a class for the related functionality. If the functionality is not related to that class, then don't put that functionality into that class, right? That there is a principle called a single responsibility principle, which we will going to discuss. That means putting more functionality on classes is a bad design. Second thing is that implementing tight coupling between the software component between the classes, right? If you are creating an instance of a class in another class, that means both the classes becomes tight coupled. And in that case, if you want to change the class, then again you need to change the class in wherever you use that class. So we should avoid these things by using loosely coupled mechanism. How we can implement this, that is also we are going to discuss in today's session. How we can overcome these problems, how we can overcome means we need to follow the correct architecture. Whether you need to follow MVC architecture, layered architecture, three-tier architecture, MVP architecture, or so on, right? As per the project requirement, right? So we need to select the correct architecture. Which architecture I need to follow? I need to follow MVC architecture, model view controller, three-tier architecture, business layer, application layer, data access layer architecture, or so on, right? As per our business requirement, we need to decide. As a developer, we need to follow the design principle. We need to follow the solid design principle 100%. Because see, whenever I'm saying design pattern and the design principle, they are nothing but effectively utilizing the OOPS concept, right? So don't think that these are rocket science, right? Solid design principle or any design patterns, whatever you are going to learn, they are not rocket science. They are just better utilization of the OOPS concept. If you are good enough in OOPS concept, then you can easily understand these things very easily. For these things, we are not going to write any kind of say, don't think that a .NET framework or Java, they are providing some specific syntaxes, right, to implement solid principle. Don't think that. So solid principle means it is just the OOPS concept better. How you are writing the OOPS concept in a better manner, that is solid. Or any design pattern you take into consideration, they are just better utilization of the OOPS concept, nothing else, right? For each design pattern, they are specifically solving one design problem. That is what we are going to understand, right? So what we are going to discuss, we are going to discuss each design principle. Solid means there are 5 design principle. We will start discussing what is that design principle. We'll see example without following that design principle. We will identify what is the problem of that design principle. We will see example following the design principle, and finally we will see what are the advantages of using that particular design principle. So in that way, we are going to design, we are going to learn in today's session. So what are solid principles? So solid design principle are the design principle that basically used to manage most of the software design problems that generally we as a developer encounter in our day-to-day programming. These design principles are tested and proven mechanisms that will make the software design more understandable, more flexible, and more maintainable. As a result, if we follow this design principle while design our application, then we can develop better applications, right? So basically, solid design principle, what we are going to learn, it represents 5 design principles. So each word in solid represent one principle. So let us start what are the principle, and then we will discuss each principle in detail. What is S? S stand for single responsibility principle, which you can also call as SRP. What is SRP principle saying? This principle states that each software model or class should have only one reason to change, or we can say that each model or class should have only one responsibility to do. I know this is not clear at the moment, but don't worry. This is just the definition. We will explain this definition in detail. We'll try to understand the definition by taking the examples also, right? So then the second design principle is open closed principle. You can see the second letter of solid is O. O stands for open closed principle, which you can also call as OSP, right? What this principle says that open closed principle says that software entities such as model classes function should be open for extension but closed for modification. Again, we'll discuss what is the meaning of this definition. L stands for list of substitution principle. So this principle says that object of a derived class should be able to replace an object of the base class without bringing any error in the system or modifying the behavior of the class. I stands for interface segregation principle. This principle is also called as ISP, right? This principle says that clients should not be forced to implement any methods they don't use. Rather than one fat interface, numerous little interfaces are prepared based on group of methods with each interface serving one submodel. I know this thing, these are the definition. Let us first read the definition. Then we will understand each and everything in detail. D stands for dependency inversion principle. This principle states that high-level modular classes should not depend on low-level modular classes. Both should depend on abstraction. Secondly, abstraction should not depend upon details. Details should depend on abstraction. So these are the definition. Let us start our discussion with this single responsibility principle. Okay. right? So, anybody having any idea related to this single responsibility principle?
Means like a class should have only one responsible.
So, what it means? That's absolutely fine. A class should have only one responsibility to do. But what?
Maybe functionality wise, the options are limited perhaps
Okay,
in this.
limited in the sense what? Function-wise limited means?
Limited means, see, you cannot have multiple kind of functionalities to work. I'm not very sure, but
Yes.
this is what I guess. Yeah.
This, yeah, that is right, right. So multiple functionality means you should not implement multiple or different kind of functionality in a class. Any other answer from anyone else? Okay. So let us start by reading the definition. Each software model or class should have only one reason to change. In other words, we can say that each model or class should have only one responsibility to do. So what it means? It means we need to design the software in such a way that everything in a class or model should be related to a single responsibility. Single responsibility doesn't mean that only one method. Single responsibility means as long as multiple methods are related to a single functionality, you can put them inside a single class, right? So basically, you need to design the class, and that class should have only one kind of a responsibility. For example, if you are designing one class, right? uh, for the invoice, then only the invoice related things will be put inside that class. Creating invoice, sending, deleting invoice, right? Those things you will put inside that class. Other responsibility like sending email, logging the information, right? Creating creating the product, making the payment. Those are not related to the invoice, right? Invoice means only creating the invoice or deleting the invoice. Those things you should put inside the class. You should not put the logging activities, sending email activities, getting the employee information, updating the student information. Those are not related to the invoice, then don't put those functionality inside the invoice class. So basically, you need to design the class in such a way that only the related functions should be there. Unrelated function should not be inside that class. Then what will happen? Now, in that case, suppose your class having only invoice related functionality. So when you need to change the class means whenever the change comes for the invoice, you should not change the invoice class if the request is coming to update the employee information, but you are doing that functionality inside the invoice class. That should not be the case, right? So you can have multiple methods inside a class as long as all those methods or properties are belongs to a single responsibility or functionality. If the functionality is not related to that class, then don't put that functionality inside that class. So with the help of SRP, what will happen? The classes become smaller and cleaner. And but the point that you need to remember, when small things makes you understanding the concept clear. If you are having a small class, you can easily understand that class. If you are having a small method, then also you can easily understand the code. As bigger the class, as bigger the method, that bigger the difficulty to understand the application code. So always try to make the class as smaller as possible. Always try to make the method smaller as possible, right? So so before proceeding, let us first try to understand what is meant by responsibility, right? What is responsibility? See, an application can have many functionality. Many functionality means many features. For example, if you are developing an e-commerce application, then that application may have many functionalities. What are the functionality? You might be asking the user for registration. Once the user registered, then you are providing the login functionality. Then once the user login, then you are showing the list of a product, right? And from the product, you are allowing the user to place an order. While the user placing the order, you are providing the payment functionality, right? Once the payment is done, then you are shipping the order, you are billing the order, right? And while the transaction is processing, every step you are logging into the database, or you are logging that in all those information in the log file, right? So that means all these things are nothing but one function. You can consider these functionalities or feature as a responsibility. And another point that you need to remember is changing the functionality means you need to change the class that is responsible for that functionality, right? So that is what I'm saying here. Only one responsibility to do. So changing the functionality means you need to change the class that is responsible for that functionality. With this keep in mind, let us proceed and understand the single responsibility principle. Suppose we need to design an invoice class. As you know, invoice class basically used to calculate various amount based on its data. The invoice class doesn't know how to retrieve the data or how to format the data for displaying, printing, logging, sending an email. See, if you are working with the invoice class, then its main objective is to calculate the amount, right? What should be the invoice amount? But this class should not have any idea how to format the data, how to retrieve the data, so how you are going to display the data, how you are printing the data, logging the information, sending the email. Those things should not be related to the invoice class. Invoice class means only the invoice related activity. Create an add an invoice or create invoice, delete invoice. So if we write the database logic, business logic, as well as display logic in a single class, then our class performs multiple responsibility, right? So if you are creating a class, that class having the database logic, that class is interacting with the database, getting the data, again performing the business logic, as well as the same class is also going to display the data in the console, right? Or that means one class is responsible for three activities: database logic, business logic, display logic, right? Right. If you are putting all these three logic, right, inside a single class, that means you are violating the solid design principle. One class should have only one responsibility. Data access logic means that should be a separate class. Business logic means that should be a separate class. Display logic means that should be a separate class. They should not be put together inside a single class. If we are putting all these things in a single class, then it's very difficult to change one responsibility without breaking the other responsibility. For example, if you want to modify the business logic, then you need to make sure that not only the business logic, but the data access logic, the display logic, whatever written inside that class, those are also working as expected. So by mixing multiple responsibility into a single class, we are getting this problem. So what are the problem? Difficult to understand, right? So if you are writing everything inside a class, your class will become a bigger one. Bigger means difficult to understand, difficult to unit test, right? So you are putting means if you want to test, then you might face some difficulty while testing and chances of duplicating the logic, right? Suppose some business logic you have hard coded inside the class, and the same business logic is required in a different module. Then again, you have to write the same logic at that place also. So what it means? It means there might be the chance of duplicating the same logic at different places of the applications, right? So let us first understand the single responsibility principle without following the one example, without following the SRP principle. Then we will see the problem, and then we will see how we can overcome this problem using the SRP principle. So basically, we need to design one class, invoice class. So you can see currently what I'm doing inside my invoice class, right? I'm putting four functionality. One is add invoice, delete invoice. These are the one responsibility of invoice class. We should put this responsibility inside the invoice class. But apart from these two, once the invoice is generated, we are sending the invoice to the user. We are logging the error information, right? Debug information, every information, right? At logging information, we are also putting inside the invoice class. But these are not the one responsibility of invoice class. So these are extra responsibility. So as we are putting one responsibility plus extra responsibility within a single class means what? Means we are violating the SRP principle, right? So let us understand this with an example, right? Let me create a project. Right, so this is your my project. Let me copy these codes. Let me create a class file. Let me give the class name as invoice. Copy paste the code, right? So in this case, say this is my invoice class, and let me increase the font size. Right, so you can see this is my add invoice. This is his own responsibility. I have not written the logic, but I'm just showing you. So in this case, what I'm doing, I'm sending the email. Here we need to write a code for adding invoice. Once the invoice is added, then send the email. Here you can see I'm sending the email, and any error occur that I'm logging here, right? Then this is my delete invoice. So again, I'm going to delete the invoice. If any error occur, then I'm logging the error information, right? And this is send invoice mail. So this method should not be inside this class. Add invoice, delete invoice. This is the one responsibility. These two methods, these two responsibility, these two functionality are related to invoice. So we should put them inside this class. For send invoice email, right? This is unsending email activity. There is no link between this invoice class and this send invoice email class, right? So again, and here you can see this method should not be here. And again, here we are writing the system dot write all text, right? Logging activities. This should not be inside this class, right? So currently the way we have written the code, right? This is violating the SRP principle. As per SRP principle, your class should have only one reason to change. Now, if I'm going to change this invoice class, then the region only invoice, not other thing, right? So now, if you want to modify the email activity, right? Send email means what? Now, yeah, you currently you are sending the email, and now you have not included the CC information while sending the mail. Now the user, the client wants that while sending the email to the user, please put my email ID in the CC or VCC. Then for that purpose, you need to change the send email activity. Again, what you need to do? You need to come this class and you need to modify the code here. That means we are changing the invoice class for the responsibility, which is not add invoice, delete invoice, but for the responsibility of an email. Again, suppose you are writing the text, right? You are logging the information in this manner. But now you don't want to use the log information in this manner. Rather than you are going to write the error information in a different manner. That means again you need to come to this class. You need to write. You need to update. You need to change this method, right? You need to also change this method. That means you are changing the invoice class for the logging, for the responsibility logging, right? That should not be the case. That means as for the single responsibility principle, a class should have only one region to change. One region means only one responsibility. One responsibility means you can change the methods which are related to the class. One responsibility doesn't mean that your class having only one method. One responsibility means your class can have multiple methods as long as all those such methods belong to that class. So in this case, add invoice class, delete invoice class related to the invoice class. If you need to update the code in the add invoice, right? Currently you are doing some calculation for adding the invoice. Later the client needs some changes for the calculating the invoice. Then you can go, you can come here and do the changes. That is absolutely fine. But if you are changing the class for the email related activities, then that should not be the case. This is violating the SRP principle, right? So what is the problem? The problem is that suppose, see, once you develop this application, right, then what will happen? So you have unit test these things. You have unit test this method, this method, this method, right? And it is working fine. Later, you are coming and changing this send email invoice method. Then again, not only you have to change this method, but also you need to make sure that this add invoice method is working fine. This delete invoice method is also working fine, because you are not changing this method only. You are changing this invoice class. Invoice class means if you are changing one method inside this class, means you need to also make sure that other functionality should not be affected by the changes what I have done inside the class. Then what will happen? See, as a developer, you can do these things, right? You can, always the developer think that his code is 100% right. Always the developer feel that my code is going to work as expected. But there is a QA team, right? If you are doing some changes, then you need to inform the QA team earlier. Hey, Mr. QA team, I'm going to do some kind of changes for the email related activities, and be prepared for the regression testing, right? Then they can prepare the test cases and they can do the test, right? That means, and they are not only going to test these things, right? Because the QA team cannot individually test its functionality. They need to do this testing as well as this test. That means it will become very difficult for us as a developer to handle the things as well as for the QA team to do the regression testing. So we should not put all the functionalities inside a single class, right? If the functionality is not related to the class, if the functionality is related to the class, no issue. You can put that functionality inside that invoice class, right? Inside that class, whether it is a new functionality, updating the functionality, modifying the functionality, no issue. You can do this. But if that is not related to the class, then don't put that functionality within that class. So if you are designing the application in this way, then you will face the problem. What is the problem? Once you do modification to this class, then again you need to do testing this class. You need to also test this class as well. Clear, guys?
Sir, one doubt.
Yeah.
Uh, how do we decide that, suppose all these activity related to invoice only? So how do we decide like what should be, how do we segregate actually, whether
Exactly.
it is,
Okay. Okay. Suppose you are creating one employee class, right? Suppose you are creating an employee class. Employee class means what? Only employee related activities you can do inside that. That is add employee, right? You can update employee, right? You can delete employee like this, right? Delete employee. And another you can also use get employee, right? Then this is one activities. Then you want to provide logging activity. Yes, I need to create a class called the logging. And inside that logging class, I need to provide a function for info. If you want to log some info method is there. Some debug method is there, right? Some error method is there. I need to create one email class, right? Inside that email class, I need to provide the functionality for send email, right? Send email with attachment, right? So in this case, you can decide like this. Suppose I need to generate one invoice class. Inside this invoice class, I need to call add invoice, right? You need to create a delete invoice. See, in this case, I have created here 4 method, here 3 method, here 2 method, here 2 method. If possible, I can create a single class. I can put all these things together. But that is the design principle, means it is your thought process. How you are going to design the class. First of all, if you are creating one method, then you need to identify whether it is good enough to put this method inside this class or not. In this case, does it make sense to add these 2 methods inside this class? Does it make sense? Or do you think that adding these 2 methods inside this class does make any sense?
no, sir.
So
No, this is the problem actually we are facing.
exactly.
Because, yeah, the developer, before giving the FRS, he mentions the functionalities and all that. And gradually, when we ask him to provide additional functionalities as a part of change management, what he does is he includes everything in the class. With the result, the software, the way in which the software runs, it goes slow, number one. Number two, thing is, we are not able to understand, as you rightly pointed out. Suppose if you have a change management, like If I give it to a new developer, the new developer himself takes a lot of time to understand the logic behind the coding that is involved.
Exactly. And
Yeah.
this is the problem because we are not following the proper design principle and design pattern. So it is your thought process. See, employee class means only the functionality which are related to the employee. Tomorrow, a new functionality come for the employee related activities. Then you can go and put that functionality inside the employee class. But if your application design is started in such a way that everything is inside one class, then you cannot do anything. You cannot do you later you are coming, and if you are thinking that I need to redesign the application from the scratch, that is impossible. You cannot do that because the project, see, most of the time your manager will say that yeah, this code is working, this project is working, don't do anything that will impact the production, right? So basically this is from the initial moment, right? Once you start developing the application, before that you need to design the application means you need to decide what are the classes I need to create, right? If you remember, while discussing the inheritance concept, at that time I have decided how you are going to design the application, what is the application, what are the entities, what are the attribute, what are the common attribute, how we can design the inheritance relationship, right? In the same way, right, that is for one model. Again, if you are having different models, right, then for each model you need to identify what are the entity I need to design, what are the classes, right? So basically you need to properly follow the solid principle. If you are not following, then you will face the problem. Similarly, in this case, you can see I'm not only putting add invoice and delete invoice, but also I'm putting this mail message, sending email activities, I'm putting this logging information, right? Everything I'm putting inside the single class. Tomorrow you want to change this write all text method, you have to come here and you need to do changes to this class, this method. But this changes, right? Here you are changing the logging information, but that logging information should not have any link with this add invoice method. Then why, if it is not related for to add invoice, then why I'm going to do the changes? I need to design the application in such a way that this code should be somewhere else. I just need to call that method from here by passing the required information, what you want to log in the log file. And that method will take the responsibility how he is going to log the information. Any changes, any modification, you will do inside that method, not here. That is how we are going to design the application. So this is the problem if you are not following the single responsibility principle. Any question from anyone else?
Sir, here can't we think like create is a one responsibility, delete is a one responsibility like that for employee?
Sorry.
Can't we think like update is one responsibility, delete is one responsibility, get employee is one responsibility individually?
Yeah, they are individual. See, individual means what? So you mean you need to create one class for add employee, another class for update employee?
Yeah, yes, yes.
So, but in that case, suppose that employee class, right, having some properties, 4 properties and 5 properties. Then do you think that suppose this employee class having this ID, name, gender, salary, right? Then do you think that you need to copy paste these 4 properties in individual classes?
No.
Then see, if you are adding one employee means you need employee information. Employee information means ID, name, gender, salary. If you are creating one class for add employee, then what information or what properties you will put inside that class? No, disable info. Right? Understood? Give
Yes,
me
sir.
1 minute, guys.
Okay.
Right? So Okay. So means what? Now, a single responsibility principle doesn't mean that one class having only one method. It means that you can have a multiple method as long as those methods, right? As long as those methods belonging to that particular class. That is the meaning of single responsibility principle. Single responsibility doesn't mean one class having only one method. It means multiple method can have inside that class as long as all those methods are related to that class. So in this case, add employee, update employee, delete employee, get employee, right? All these methods are related to employee class. So you can put them inside this class. Understand, guys?
Yeah, understand, sir. Thank you.
Yes, interrelated. Yeah.
Right, interrelate. See, in this case, logging. So you want to log the info, you want to log the debug information, you want to log the error information, right? So these three methods are related to logging class, so you can put them here, right? Any more logging active functionality you require, you can add them inside this logging class. Now send email with attachment, right? Any other functionality you want, you can create an email logger class. Inside that email class, you can put those functionality. Add invoice, delete invoice, any more invoice type you want to create, right? You can put them inside this class. You want to modify add invoice logic, you can command modify here. There is no link with these three other classes. But if you put all these things inside a single class, whenever do the changes, then you need to completely test all the whole class, right? So this is the problem and this is the solution. The problem is you should not put unrelated activities or unrelated function within a class. Solution means each class should have only one responsibility. One responsibility doesn't mean one method. One responsibility, multiple method, but if all those methods are related to that particular class. Right. So this is the problem, and now we need to find the solution. What is the solution? For our example, we need to design three classes. One is invoice class, where we will put the add invoice and delete invoice. Email class, where we will put the sending email logic. Logger class, where we will write the error logging or any logging related activities that we will put inside this logger class. So let us start the discussion, right? Let us create the logger class. Okay, let me go and write a class called logger.cs, right? So this is my logger class, and inside this logger class, what I'm going to do, right? I'm creating a iLogger interface, right? And I always prefer to use interface based because this will make your intention clear. It will always better to start with the interface, right? Here in my interface, I have created three methods. One is string info. This is the debug method, and this is the error method, a message exception, right? If you want multiple methods, so you can also write like this. Only information, only exception details you want to put, you can also write like this, right? So once you put this thing, then you will get one exception. Then for that purpose, you need to provide the implementation for that method, right? So now this is my logger class, right? So you can see iLogger interface, logger class implementing the iLogger interface and providing the implementation for all the four methods, right? 1, 2, 3, 4. You can say this is one method, this is another method, another two method, right? Here, this is the constructor. Here we need to write the code for initialization, that is creating the log file with the necessary details. Necessary details means what? Suppose where you want to, you are using nlogger, right? Then that instance, nlogger instance creation logic, you need to write here. And that once that created, then you can use that instance directly inside this method to log the information. Or if you are having some if you want to put the logic in the text file or into the database, right, that initialization logic you need to write here, right? So this is how you need to design the logger class. Now if you want to change the log related activities functionality, then you do not need to go anywhere else. You just need to come here and you just need to modify the changes, right, as per your requirement. You want to change the info method, you want to change the debug method, directly come here and modify the method. You want to create a new method, okay, come here and declare the method first here like this, and then provide implementation. right? So this is how you need to design the logger class, right? And the second one is we need to design the one class for mail sending activity, right? So for that purpose, what I'm trying to do, I'm creating a class called mail sender, mailsender.cs, right? And inside this class, you need to write the logic, right? So inside this class, mail sender class, you can see this mail sender class having some information, email from, uh, email to, from which email I need to send them, to from which mail to which mail, email ID I need to send the mail. What is the subject of the email body, you need some attachment, any kind of information, you can create another method, right? Send email with attachment like this, and that will going to contain, right, that will going to contain the logic to send the email with attachment. Right now this mail sender is specifically designed, to handle the email related activities, right? If you want to change email related things, then you need to come to the mail sender class. If you want to change the logging related activities, then you need to come to the logger.cs class file, and here you need to change the things, right? And once with these changes, now what we need to do, we need to modify the send, we need to modify our invoice class, right? Now the invoice class should not have those additional activities, right? So you can see this email class having the add invoice method and this delete invoice method, right? ex.message. Okay, so let me do one thing. So let me create exception message. Right? String info and string error message, right? So you can see now what I'm doing. So this class having say, invoice amount, invoice date. Apart from that, as this class going to interact with the mail sender and logger class. So what I'm doing here, I'm creating two private variable for file logger and email sender. These two variable I have initialized within my constructor. Right? File logger equals to new my file logger, email sender, right? And then what I'm doing, add invoice method, right? So if you want to log some information, you right? So you can see this add invoice method. Now, if you want to log something, you just need to call the info method, right? How this info method is implemented, that I don't care, right? Right now, the add invoice method doesn't care about how this info method is implemented. You know, this is the method which is used for logging, and I just need to pass the message. That's it. Right now, once the invoice is created, then you just need to call the send email method. How this send email method is implemented, that is not my responsibility. So I just need to create the email from email to email subject, email body, and we just need to pass this information and call this send email method. And that send email method is implemented here, right? And then any error occur, then I'm just going to call this error error method, right? How this implemented, that is not my responsibility. I'm just going to use any changes you required in the error method logic, that you need to come to here and you need to change the logic here, right? Similarly, delete invoice, you can see file logger.info. I'm just calling, I'm not implemented the logic here, right? I'm just showing you how you need to design the class. Clear, guys? Now, this invoice class having only the activities which is related to add invoice and delete invoice. Logger class having all the method logic to log the data into the log file. Mail sender will have the responsibility to send the email. Clear, guys?
Yes.
So this is how you need to implement the SRP principle. Right? SRP principle means only one class have only one responsibility to do. Any question from anyone?
So just one question, like the single responsibility is clear, but you are creating a instance of invoice and initializing the methods of those invoice method through that creation of that invoice class. Is it
Exactly.
in
See,
this?
in this case, see, if your class needs to communicate with other class, suppose you are having one class, right? And that class wants to call some method of a different class. Without creating instance, can you call that method?
No.
So that is the reason. If I want to log some information, then definitely I need to use the logger class and these methods. If I'm not creating an instance of this class, then how I can call these methods? So for that purpose, I'm creating that instance. See, creating this instance will not make that effect because you are not going to change these classes, right? The logic, see, whenever change request comes means you need to change the logic. Logic means what? The method where you define. And for this info method, where the definition is there, the info method definition is within this invoice class or within the logger class. If you want to modify the info method, then you need to come to this invoice class or you need to go to the logger class. Hello?
Sorry, sir. Can you ask it?
So if you want to modify the info method logic, right, then you need to come to the invoice class or you need to go to the logger class.
Which info, sir?
Info
Invoice
method,
info.
this info method. So the
Okay,
logic is
it
what
is
you
in
need.
logger.
Logger class. So if you are
Yeah.
changing this logic here, do you think that that will affect to this method? That will affect to this add invoice class? Do you think that? No, it will not affect. As long as the method signature is same, there is no issue. If you are thinking that this method taking one string parameter, that's it. I don't know how this parameter is going to be used by this info method. That is not the responsibility of info in this logger this invoice class. He just need to create an instance and call this method by passing some string data. That's it. How this data is going to be logged, where the data is going to be logged, that is not the responsibility of invoice class. That is the responsibility of logger class. Suppose today you are logging the information into the database. Tomorrow you want to log that information into a text file. Then where you need to do the changes? You need to do the changes in the invoice class or in the logger class. Where?
In the logger class.
Exactly. So now you clear why I'm creating this. If I'm not creating this instance, right? If I'm not creating this instance, then how I can call this method? I want to log the data, but how? From add invoice method, how I can log the data? That information logging should be there, but that information logging activity, that functionality is not implemented here. I'm just calling that method, but that method is implemented inside this logger class. If you want to change, then you have to change here. Clear, guys?
So if we are creating the instance of invoice, then the instance of logger class and mail sender also will be created along with that, no?
Exactly, exactly. So if
Okay.
you are creating an instance of this class invoice, right? Invoice equals to new invoice. So in that case, this is the constructor. Yes or no? So basically, this is the oops concept. This is the constructor. That means this constructor is going to be execute. If this constructor is going to be execute, this two will be initialized or not. And then you
Yes.
can call the add invoice and what I can say, the method whatever. Suppose invoice dot add invoice, you can call here, right?
Yeah.
Got it?
So for basically for every entity, it's better to have a different class of responsibility or CRUD
No,
operations
no.
related to that.
Yeah, so if entity means, if you are creating an entity means only the related activities of that entity should be put inside that class. Non-related activities should be avoided. Clear?
Yeah, got it.
Okay. And anyone having any more question?
No.
Okay. So the next principle what we are going to discuss is open closed principle. Right? Let us first understand what is this open closed principle. Then we will see one example without following the open closed principle. We will see the problem, and then we'll see how we can overcome those problems by following the open closed or OCP principle. Software entities such as module, classes, and functions should be open for extension but closed for modification. So here we need to understand what we mean by open for extension and what we mean by closed for modification and what we mean by this definition. Let us simplify this definition part. Here we need to understand two things. First is open for extension. What do we mean by open for extension? And second thing is closed for modification. The open for extension means we need to design the software module, classes, or functions in such a way that new responsibility or functionality should be added easily when a new requirement comes. So we need to design the class in such a way that, or we need to design the function in such a way that whenever the new responsibility come, whenever the new functionality come, they can easily add it. On the other hand, closed for modification means, right, we should not modify the class model and function until we find some bugs, right? That means if you are finding, see, you need to design one class. That class having some functionality. If you are going to add some functionality, then you should add those functionality easily, but you should not modify the functionality, right? Some bugs is arises, that is fine, you need to fix the bug, but you should not modify the code. If you want, if new functionality come, you can add those functionality, but you should not modify the existing functionality. Why is this? The reason for this is we have already developed a class model or function, and it has already gone through the unit testing phase. If you developed one function or if you develop one class, then that already gone through unit testing phase. So we should not have to change this as it affects the existing functionality. Like the way we have discussed in SRP, if you are changing one existing functionality, then that means we need to test the whole class. In simple word, we can say that we should develop one model function, right, or class in such a that it should allow its behavior to be extended without altering the source code. If you are having one class, then if you want to extend the behavior, extend the functionality, then that should be extended, but you should not touch the existing code. But if that means we should not edit. So we are not touching the existing code means what? We should not edit the existing code, or edit the existing code means what? We should not edit the code of a method until we find some bugs. Instead, we should use some kind of a inheritance, or some kind of a polymorphism concept, right, to add the new functionality. If this is not clear at the moment, what do we mean by open for extension and closed for modification? Don't worry, once we start discussing the practical example, then you will understand this concept. Then how to implement this? What is the guidelines that we need to follow? The easiest way to implement open closed principle in C# is to add new functionality by creating, give me 1 minute, guys. Okay. So how we can implement this? Now, the easiest way to implement OCP is to add a new functionality by creating a new derived classes which should be inherited from the base class. Another way is to allow the client to access the original class with an interface, with an abstract interface, right? So let us understand this with an example, right? Suppose, right, see, we are having the invoice class, right? We need to calculate the get invoice discount, right? So if you look at this logic, right, let me increase the size, right? So this is the final amount. This method taking some amount and it is taking some invoice type enum. And based on the invoice type enum, it will calculate the final amount, right? So currently you can see I'm having two invoice types, right? In the invoice type enum, we are having final invoice and proposed invoice, right? So you can see here I'm using the if else condition and I'm calculating the invoice type. Now this is the design what we are currently following. But now, apart from these two invoice, right, one more invoice type come into the picture. Then what you will do? So final invoice, proposed invoice, or you can say recurring invoice, right? Another invoice type will come into the picture, and the client needs that, hey, Mr. Developer, now that two invoice type is working fine, but now I want to introduce the third invoice type, and that invoice type is a recurring invoice. Then what you will do? You generally intended to add another enum inside this invoice type class, and you need to add another if else condition inside this get discount method. Yes or no?
Yes.
Yes, that is the problem. The problem is that open closed principle saying that open for extension but closed for modification. So in this case, you are trying to add a new functionality. New functionality means you are having two functionality. One is calculating the final invoice, another is for calculating the proposed invoice. And now you are going to add a new functionality, that is recurring invoice. Whenever you are trying to add a new functionality, then that should be extended, right? That is open for extension means you can extend the class so that you can have that additional functionality, but closed for modification. You should not touch the existing method code for the new functionality. So in this case, I want to in this case, I want to add a new functionality, but for that purpose, I am modifying the existing get discount method. This is the problem. If you are adding another if else condition here, then this is the problem. This is against the OCP principle because you are you are modifying the existing method code for additional or for better to say for new functionality. For new functionality, you are updating the existing code. This is against the OCP principle. Yes, if you have written the logic to calculate some invoice amount, if there is some issue, there is some bug, then you can come and update this get discount method. But the get discount method should not be there for the new functionality, right? Today we are having this two invoice type. Tomorrow I'm having another invoice. Again, after some day, right, another invoice type will come into the picture. Then again and again new invoice types are coming into the picture. Then again and again we are coming to this get invoice discount method, adding one more if else another if else condition again and again. Then what is the problem? The problem is if we are adding another invoice type, then we need to not only we need to check that invoice type working as expected or not, but also we need to check the existing invoice, right? Whatever final invoice, purpose invoice logic we have implemented, those are affected or not, those are working as expected or not. That also we need to check. So this is the problem of this design. Let us implement this with an example. Let me add a new class to this solution, new project to this solution. Let me give the project name as Solid Principle OCP, right? Let me make this as my startup project, right? So inside this project, let me create a class called invoice. invoice.cs. Inside this class, let me copy paste this code. Right. So this is the problem. So you can see whatever we discussed, this is the logic. So the problem is for new functionality, we are updating, we are modifying the existing code, which is against the OCP principle, open closed principle. Open closed principle saying that open for extension. If you want to add a new functionality, you can add the new functionality by creating new derived classes, but closed for modification. You should not touch the existing code for new functionality. Now, if you want to add a new functionality, then you need to touch the existing code. This should not be the case. So if we are not following the open closed principle, then what problem we are facing? If you allow a class or function to add new logic, then as a developer, you need to test the entire functionality, which include the old functionality as well as new functionality. Right. So in this case, if I'm adding another invoice type, let me give a right. So suppose I'm adding another invoice type. Then what you need to do? You need to write another if else condition. Then if you write another if else condition, then what will happen? Right? Then what will happen? Then not only you need to unit test this functionality, but you also need to unit test whether this is working fine or not, that is working fine or not, and obviously you need to test this one. So this is the problem. As a developer, it is also your responsibility to tell the QA team about the change in advance so that they can prepare themselves in advance for regression testing along with the new feature. Regression testing means all the functionality along with the new functionality, they need to prepare themselves so that they can test the same. That you need to tell to the QA team. If you are not following the OCP principle, then it also breaks the single responsibility principle as the class or a model is going to perform multiple responsibility. Right? If you are implementing all the functionality in a single class, then the maintenance of the class also becomes very difficult. Right? So now currently you are having 3 different types of invoice. Tomorrow another 5 different types of. So don't think that it is limited to invoice. Right? Many things. Right? I see many developers, they are just writing the code in this way. They are just writing if else if like this, and and again new features come. They are just writing another if else if condition to their existing code, right? That should not be the case, because if you write like, see, in this case, this is having only one line of code. But don't think that is the logic what you are going to write always one line of code. It might possible that it is 10-50 line of code. Here you need to write 100 line of code. That means you can imagine how long this get discount method is going to be. As long as you are adding the new functionality with the existing method, the code is going to be increased as again and again, right? That means we should not to do this. Maintenance, we should keep maintenance on our mind, and we should need to maintain the code as possible as it is. As I'm saying again and again, as small as the class is, as small as the method is, as better as the maintaining the code, understanding the code is. As bigger the class, as bigger the method, maintaining the code is also going to be a headache for the developer. So we need to consider small things is always better in terms of programming, right? So we should not do this. Now, what we need to do, we need to implement open close principle, means instead of modifying, we should go for extension. How we are going to do this? So how we are going to do this, let us understand. Right? So basically what we need to do, final invoice, let me create a few classes. So invoice class is there. So what we need to do, I need to create one class, final invoice.cs. Right? Then inside this final invoice.cs class, I need to copy paste this code. Okay, let me first modify the invoice class. Invoice class. Okay, let me close all these things. Right, this is my invoice class. This is my invoice class. This invoice class having the get invoice discount method, and it is the returning the base amount. If you want, you can also make this as an interface, and you just need to declare the method. But here I'm declaring this method class, this as a class, and I'm making this method as virtual. So I'm making this method as virtual means the child class can override this method, right? So then I'm creating three different classes, right? The final invoice. So I'm modifying the logic. You can see this final invoice class is inherited from the invoice class. Then I'm having the proposed invoice. Let me create another class file. Proposed invoice.cs, and within this class, let me copy paste this code. So this is the proposed invoice, and the logic is written here. Currently, we are having two invoices, final invoice and the proposed invoice. That is fine. Now, what is our requirement? We need to introduce a new invoice into our application. For that, we do not need to touch this class. We do not need to touch this class. We do not need to touch this class. If I'm not going to touch this final invoice class, if I'm not going to touch this proposed invoice class, if I'm not going to touch this invoice class, then we do not need to unit test these things again and again. I'm going to create a new class, recurring invoice. So if I'm creating a new class, then only I just need to test that class. So our main intention is what? We need to extend the functionality. And for extending the functionality, I'm creating new derived classes, right? And with these new derived classes, right, we do not need to touch the existing code. We are extending the functionality. We need to implement get invoice discount for recurring invoice. That is fine. We have implemented this. We are just inheriting from the invoice type, and we are just overriding the get invoice discount method and providing implementation, right? That's fine. So today we are having three invoices. Tomorrow new invoices come into the picture. We do not need to write this bulky if else condition inside one method, right? We just need to create a method, and we just need to inherit from the invoice type, and we just need to override the get invoice discount method. That's it. So with these changes right now, if you are creating this new invoice type, then you only need to test this one. You do not need to test this one because there is no link between this class and this class. So if you are not changing this class, then why you are going to test this class? If you are not changing this final invoice class, then why you are going to change this final invoice class? You are just creating a new class. You just need to create the test that new functionality, right? So now, if you want, then you can create, right? Then you can create the you can just modify the program class, right? So you can see let assume that the base invoice amount is this, and for this I'm creating a final invoice instance, I'm creating the proposed invoice, and I'm creating a recurring invoice, and I'm just calling the get invoice discount method. And the see, currently, suppose you have already tested these two things, right? Then you do not need to test these two cases. You just created, this is the new class. Just create an instance and call the get discount method. That's fine. And with these changes, right, run the application. Right, so invoice amount and recurring invoice, you will get the output as expected. So this is the advantages of what I can say, open closed principle. See, open for extension, but closed for modification. You should not modify your existing code for the extensibility of a feature. If you are adding a new feature, you can add that new feature by creating a new derived class, like the way we have done in this example. Any question from anyone? Guys,
No question, sir.
clear?
Yeah, clear.
Yes, sir.
Right? So it will reduce the error as we are not modifying. So advantages, if someone asks you what are the advantages, you can read it. It will reduce the error as we are not modifying the existing classes. It will allow us to add a new functionality by adding new classes where no current functionality depend on the new classes. See, do you think that this functionality will depend on this class functionality? No, they are independent, right? So it will also make sure that single responsibility is not violated because each class having only one responsibility, right? It will also allow us to unit test each class method very easily. Like, see, if you want to unit test this method, you can unit test. If you want to unit test, then you can also unit test that method very easily. So this is how you need to implement open close test. Anybody facing this issue, if else condition in their existing project? Multiple if else condition to add multiple functionality.
Yes, I have many.
I mean, you have faced this issue, or your existing project code is like this, right?
Even in our applications also, as you rightly pointed out, we suppose if we suggest any changes, the developer does the changes, but the thing is that the UIT team has to sit and test the entire thing. All the other methods also they need to test, and because if one is affected, one introduction of one additional feature in the software forces us to test all the other things also. That makes our job much more tedious, and also consistency will not be there. That is, we would have tested everything, and it is common perception that we take it for granted. Okay, we have already tested the other things, so only a new feature will test. So new feature will be all right, but what really happens at the back end is the other the features are also affected. With the result, the end user, he shoots in a mail. See, we have suggested one thing, and some other thing is happening.
Exactly, that is the problem. That is the problem if you are not following proper design principles. If your requirement come here and there, I just need to write the code. I just need to check that functionality. If that functionality is working, that's fine. But we don't care whether the other functionalities are affected by this new functionality. That we never check. But if we develop the application like this, right? There, see, in this case, I just create a new class. There is no link between this class with any other functionality, right? Then we don't need to check other functionality. We just need to check this functionality only, right? But if our application design is not that robust, then we need to check the new functionality and as well as the existing functionality, because the first impression is the last impression, right? If you are developing one application for the client and the client gives some changes, and if you made that changes is working fine, but that is affecting other existing functionality, then later on, if the client gives some requirement, then the client is going to not only check that requirement what he given to you, but also the existing changes, right? But if your application is working fine, and if you whatever changes come, if you implement that in a proper manner, which is not affecting the existing functionality, and if the client having a good impression on your project, then this will not come again and again, right? It's not going to check every functionality for a small change request, right? That is the first impression that what you need to make to the client, right? Again, it's again, as a developer, you always think that our code is working fine, right? I don't know why it is not working on the production. In my machine, it is working fine. This kind of scenario we face many times, but we don't know what exactly happening in the product. Even I also face this kind of things. In my machine, it is working fine. Why it is not working in the production? Is this kind of things happening to anyone else?
Uh, Sir, like I have one question.
Yes.
Um, so in this case, like, are you suggesting, suppose if we have a, if you, we don't know that that functionality is going to be extended further or not. How do we decide at this point of time where when we're developing basic scratch of the application,
Exactly.
and how do we implement that?
That I'm going to discuss currently. See, initially the client say, yeah, I am having to calculate the discount. So what you did, you just create this class, and you don't make this class as virtual, and you just declare this one. That is the initial requirement, right? And you just need to create an instance and call this method. It will give you the discount amount. That is the initial requirement. Later on, the client decides, right? Later on, the client decide Currently I'm having invoice. Now what I'm thinking, I'm going to create two different types of invoices. What are the invoices? One is final invoice and another is recurring invoice. Then what you will think? Okay, so what I need to do? I need to create a variable here string. What generally people are doing, invoice type, and based on the invoice type, I need to write some if else condition. So if invoice type equals to A, right? Then I need to write this logic, right? Else I need to write this logic. So in that case, what will happen now? If invoice type is A, it will return 10. If invoice type is not A, let me return 20. So generally we done this change, and while I'm calling this method, I need to pass the invoice type. This is what we generally do. Once we start doing this, we'll face the problem. If to initially one invoice type, if later the client saying there are now change this to two invoice type, then it possible that in future he is going to introduce few more different invoices types. Then you need to think that. So if client today saying from one to is changing the invoice to two types, then it might be possible that in future it might be three types, it might be five types, and so on. So you need to think in that way. So instead of creating this, so what you need to do? Okay, let me do these things very clearly, right? Right. So, and let me override, let me make this method as virtual. As the client saying two different types, okay, let me introduce two classes. One is proposed invoice and one is final invoice. Let the class inherited from this invoice class, and let me override the method. Now, client required final invoice, create an instance of final invoice. Client required proposed invoice, create an instance of proposed invoice. Client required an invoice of recurring time, use this recurring invoice, right? So this is how you need to think about the design. And it's completely depend on your thought process, how you are thinking the future changes, right? If you are not thinking, right, a good developer is a good thinker. If you are not thinking about the requirement, about the future changes, how I can design the application so that, see, always whenever you are developing the application, always think the maintenance, always think the future enhancement. If not today, what will happen if tomorrow these things come into the picture? How I can handle this thing, how I can tackle this thing. That thinking capacity should be should a developer have. If the thinking capacity is not there, then nowadays robot are also going to write the code. Then what is the difference between we and a robot? So we are having human being. We need to think how I can design the application in a better manner. Understand?
Yes, sir, I got it. And in that regard, can we declare, like if we suspect that okay, this functionality may extend in future, can we declare now itself it as a virtual method and keep it for future development, or if we
See,
develop,
currently, you just tell me if you are currently creating this method as an invoice, and if you are thinking that this is the only class, there is no child class, then why you should make this method as virtual? Later, if you are thinking, yeah, now I need to make this class as a parent class, child classes will be there, then at that time you can make the method as virtual. Right, making the method virtual doesn't make any impact, right? If no child classes, then doesn't make this method as virtual. When the child class is introduced, then at that time make the method as virtual so that the child classes can override the method.
okay, got it.
Right? Any question from anyone else related to this?
No.
Okay, now let us proceed with the next principle, Liskov substitution principle.
So please zoom in.
Hmm?
Yeah, please zoom in, sir. Can you please enlarge Word document? Thank you.
Okay, so what is Liskov substitution principle? I don't know why it is not. Okay. So Liskov substitution principle says that object of a derived class should be able to replace an object of the base class without bringing any error in the system or modifying the behavior of the base class. So if you know one of the inheritance rule, a parent class object reference variable can hold the child class object or child class instance, right? So if you are creating a parent instance and if you are able to replace that instance with the child class, then the behavior should not be changed, right? That is what the meaning of Liskov substitution principle. That means the child class object should be able to replace parent class object without compromising application integrity. Let us understand what it means. It means when we have a parent-child relationship, that is inheritance relationship between two classes, then if we successfully replace the object or instance of a parent class with an object or instance of the child class without affecting the behavior of the base class instance, then it is said to be in a list of substitution principle. If you are not understanding what we mean by this, then don't worry. Once you start discussing the practical example, then you will understand this thing, right? See, we know the concept inheritance. We know the concept inheritance. In that case, what will happen? Now, the parent class properties methods are inherited to the child class. But as we have the concept inheritance, that doesn't mean we can make the inheritance relationship with one with anyone. Do you think that is there any link between making a relationship with the one employee with the student class? Is there any relationship making between product and a student employee class? Do you think, see, even though, right, even though in a family there is a father, there is a son. If father is a teacher and son is a doctor, do you think that it does make any sense to make the relationship between them? If you are establishing the relationship, you will not get any error, but the behavior is going to be changed, right? A father cannot be a teacher or a teacher cannot be a father. So in that case, even though belongs to the same family, so it doesn't make any sense to make the relationship between them, as if we are making the relationship between them, the behavior is going to be changed, right? So let us understand this with one example so that you will get some better idea, right? Let me create another project to this solution. I'm giving the name as solid principle.lsp, list of substitution principle. Make this as the startup project, right? And let us modify the main method, right? Right? Right. So you can say here I'm having. Hello, anybody saying anything? Okay. So you can see here I'm having one class called apple, and here I'm having another class called orange. And here this class having get color method, and here also this class having the get color method, right? Now what I'm doing from my main method, I'm creating an instance of apple, calling the get color method. I'm creating an instance of orange and calling the get color method, right? So with these changes, right, if I run the application, so with these changes, if I run the application, then I will get the output as expected, right? There are build error. Okay, what is the error? Okay, so we need to declare this as, right? Okay, now run the application and you will get the output as expected. So for the apple object, it is going to display the apple current color as red. For the orange, it is going to display the color as orange. That is fine. Now what I'm thinking, okay, let me create this orange class inherited from the apple class. Now what I'm trying to make is, I'm making apple as the parent class and orange as the child class. So for that purpose, what I'm making this method as virtual, and I'm overriding that method in the child class, right? If I'm doing this, then now apple will become the parent class and orange will become the child class. So in that case, can we store the orange class instance inside the apple class? Is that possible?
No,
Why no? In this
we
case,
can we
we
can
can. This
store
is the,
orange in.
if we can store orange class instance inside the apple class reference variable, because apple is the parent class, orange is the child class. A parent class reference variable can hold the child class object instance. There is no issue, because this is the rule of inheritance. As per inheritance, if we are making the inheritance relationship between two classes, then the parent class reference variable can hold the child class object instance. So in this case, can I store like this? That is fine. Any
Yes,
issue? There is no
no,
issue.
as functionality wise it is fine, sir, but character wise,
Exactly. That is what I'm going to tell. So in this case, as you make the inheritance relationship between these two classes, now this base class can hold the child class object instance. Then as per the list of substitution principle, the base class object reference should be replaced with the child class instance, but the behavior should not be changed. Behavior should not be changed means, in this case, base class is apple means the get color method should return me red, not it should return me orange, because an apple color cannot be orange. Apple means its color is going to be red. So in this case, if you run this application, then you will see that it is going to give me the color as orange, which should not be the case, which is changing the behavior, right? So as per the list of substitution principle, a parent class instance should be replaceable with its child class object, but the behavior should not be altered. Behavior should not be changed. But in this case, the way we have implemented the code, the behavior is changed. Yes or no? This is against the list of substitution principle. List of substitution principle means the parent class object can be replaceable with its child class object, but the behavior should not be changed. But in this case, the behavior is changed. So now Apple is printing the color of orange, which should not be the case. That means there is some issue. How we can overcome this issue? See, technically or technically, programmatically, there is no error. You will not get any compilation error. You will not get any runtime error. But from the behavior point of view, right? From the output point of view, this is not wrong. This is not right. So we need to think in terms of, we need to make the inheritance relationship, we need to make the parent child relationship between them, but the behavior should not be changed. So for that purpose, what I can do is, I can create an interface. Let me call this interface as iFruit, and inside this interface, let declare this get color method. Now make this apple class inherit from iFruity interface. Let me don't make this as virtual anymore, and let this class inherited from this apple class, and just ignore this one, right? So now you can see this apple class is inherited from fruit, or orange class is inherited from fruit, right? In earlier case, what we have done this thing. So if we are making this inheritance means is a relationship. Do you think that orange is a apple? Earlier, the earlier example we have done this. Do you think that orange is a apple? So if you are making the inheritance means what? It is one kind of a is a relationship. Is a relationship. So can we speak or can we say orange is a apple? Is this sentence make sense? Guys, tell me.
No.
No, is that see, if you are having apple class, if you are having orange class, if orange is inherited from apple, right? Then in that case, do you think that Does it making any sense to say orange is apple? No, it doesn't make any sense. If it is not making any sense, no voice. Guys, am I audible to or am
Yes,
I
yes.
audible?
No,
You
no,
are
you're
audible.
audible. No,
You
you're
are
audible.
audible now. In between we lost you.
Okay. Okay, fine. So you can so you cannot say orange is apple. See, technically, though way we have written the code, it is not going to give us any compilation error or any runtime error, right? The inheritance is absolutely fine. Why? Because we can give any name. This is just a name, right? Name will not be taken by the compiler. Compiler will check the syntax, and syntactically it is fine. As syntactically it is fine, so there is no issue. But picking a sentence, making a sentence from this statement doesn't make sense. Orange is a apple doesn't make any sense. Now what I'm doing, I'm creating an interface with an abstract method, right? So by default, the interface method are public and abstract. So this is the get color method. So you need to provide implementation for this get color method within this Apple class, right? And again, I'm making this class is inherited from this iFruity interface. Now, can I say apple is a fruit? Can I say orange is a fruit? Is it make sense?
Yes.
Yes.
Yes. So now what so as who is the parent class of apple
Fruit.
iFruit.
Fruit.
and who is the parent class of orange?
The same.
Right. And guys, remember whenever you are going to define any interface in real-time application, always start with the letter I. If you remove I, then it will give you some kind of a warning, right? So what is saying name rule violation missing prefix I. If you are creating an interface, then you will get this. So you should use say and also it is saying rename iFruit to fruit, right? Fix violation. So let's fix this and it is making iFruit, right? Now you can say apple inside apple variable you cannot store orange, but let make this variable as iFruit and making this as fruit. So can I store orange here? Yes, you can store orange here. And when you call the get color method, so it is going to print you the color of the orange, right? Later, what I'm going to do, I'm doing some changes. I'm making this as apple. So once I call this, so it will give me the color of the orange and it will give me the color of apple. So always this list of substitution means it is just inheritance concept, nothing more, right? The way we are using the inheritance, the same concept, but it is making sense, right? If you are making the inheritance relationship, does it make sense? If it makes sense, then it is well and good to go. If doesn't make any sense, then you should think about it. And if you are making the parent-child relationship, please make sure the behavior is not going to be changed. So in this case, fruit, right? Now I'm creating another class. So if you are creating one employee class, right? Public class employee. And if you are inheriting from this thread, and even though if you are implementing this get color method, right? But do you think that does it make sense to make this inheritance relation? You want to get the color of the employee, but does it make sense? It is inheriting from the iFruity.
No, no.
But but if you create an instance of employee and store that here, you will not get any error, right? You will not get any error, right? But that doesn't make any sense, right? So inheritance, this Liskov substitution principle is all about making sense of the statement or of the code, whatever you are writing. Whether that code giving you makes sense, giving you sense or not, that will be identified by the Liskov substitution principle. Here, guys.
Clear.
Yes, sir. Clear.
Yes.
Okay, so guys, let's take a break for 5 minutes and then we will come and we will discuss the rest two principles. Is that fine?
Okay.
Okay.
Yeah.
Okay.
All are back?
Yes.
Okay.
Yes.
So we have two more principles that we need to discuss today. So guys, today we are discussing this one, and in the next Sunday, we are going to discuss automapper, right? Automapper is also one of the important concept which will take also more time. So I'm planning to discuss automapper in the upcoming Sunday. So be ready, right? So the next principle, what is we are going to discuss is interface segregation principle. It's very simple and very easy to understand. What he's saying, let us first see the definition. Clients should not be forced to implement any method they do not use. Rather than one fat interface, numerous little interfaces are preferred based on group of methods with each interface serving one submodel. What it means? It means he's saying that if you are declaring one interface, right? So first of all, let me tell you, if I'm having one interface and means what? That interface, inside that interface, I'm declaring some abstract methods. By default, all the methods are abstract. And the class which is going to implement that interface, that class has to provide implementation to all the abstract methods or not? Yes or no? Say,
Yes.
for example, if I'm having some interface I1, if that I1 method having I1 interface having M1, M2, M3, then if class 1 inherited from I1, then the class 1 has to provide the implementation for M1, class 1 has to provide implementation for M2, class has to provide implementation for M3 or not? That class needs to provide implementation. Yes. So what this interface segregation principle say, clients should not be forced to implement any methods they do not use, right? For example, this class having 4 methods, this interface having 4 methods, right? Now, this is also going to be implemented by this. Now, this is, let's say this is client 1, client 1. Client 1 required all these methods, that is fine. Right? This is client 2. Client 2 required only 2 methods. Client 3. Client 3 requires 3 methods. Right? Client 3 requires 3 methods. So this is my class 3. Class 3 wants to implement 3 methods. Is this possible? I want to implement 4 methods inside this class. I want to implement 2 methods here. I want to provide implementation for 3 methods here. Is this possible? Is this going to give you, it will give you any compilation error, or it will not give you any compilation error?
Compilation error, sir.
Compilation error 100%, because this is mandatory. If your interface having these things, then it is mandatory to provide implementation to all the methods. That is mandatory, and in this case you will get any compilation error. Then what you need to do? You also need to provide implementation to these 2 methods here, even though they are not related, not required by this client, not required, but you have to provide implementation. Not required, but you have to provide implementation. Here, this method 4 is also not required, but you have to provide implementation. Not required, right? Not required, but you have to provide implementation. But you have to provide implementation. Not required, but you have to provide implementation. Yes or no? This is required. This is mandatory. Even though if you implement that throw not implemented exception inside this method, but you have to provide. And this is the case which I can see in many of the existing real-time projects, right? If you are working with any kind of a real-time application, then you might be seeing that some of the methods are not required, but they are implemented with throw not implemented exception. Yes or no? Anybody having this kind of issue in any of your project? You are implementing one interface, and within that interface, you need to provide implementation for 2 or 3 methods. You do not want to provide implementation for some method. And in that case, it is not possible. Inheritance means you have to provide implementation. And in that case, you are providing implementation by throw not implemented exploit. Anybody having this kind of this kind of coding in any of your existing project? Guys, if you are not facing this, then that is fine. But in my existing project where I'm working, there I'm facing this kind of scenario, right? So according to what this interface segregation principle, clients should not be forced to implement any methods they do not use. So if the client is not required for M2 and M3, then the client should not be forced. In this case, the way we are writing our code, in this case, we are forcing the client to provide implementation for method 3 and method 4. In this case, we are forcing client 3 to provide implementation for method 4, even though that method is not required by that client. So this is against the which principle? This is against the interface segregation principle. Interface segregation principle saying that client should not be forced to provide implementation for any method which they don't require. So how we can resolve these things? So we can resolve these issues by instead of creating a fat interface, we can create many small interfaces, right? For that purpose, what I can do, I can create I1, I2, I can create I3. In I2, I want to provide this method 3 implementation, right? And in I4, I want to provide this method implementation, right? So this is how I'm providing. Now, client 1 required all methods. Let me client 1 to inherit from I1, I2, I3. Client 2 requires only 2 methods. Okay, let me remove these things. Now, if client 2 inherit from I1, then he needs to provide an implementation for method 3 and method 4, or is this going to be compiled?
No, it won't be compiled.
It won't be compiled.
No.
Why? In this case, the client 2
Client 2.
In this case, client 2 is inherited from I1. So how many methods are declared in I1?
All right, you're right. It's M1 and M2. So
Two
it will
methods
come.
only.
You're right.
Yeah.
Sorry.
He's able to get 2 methods.
So in this case, it will combine. Now client 3 requires method 1, method 2, method 3. Let this client 2 to inherit from interface 1 and interface 2. As we are creating this as interface, so multiple inheritance is possible. So one class can inherited from more number of interface. That is fine. Now, as we have split that big interface into numerous small interfaces, now based on the requirement, the client, if required all methods to be implemented, he needs to provide implementation to all this method. If he required few methods, then as per the requirement, he needs to provide implementation. He needs to inherit it from the appropriate interface and needs to provide implementation to the required method. So with these changes, the client will not be forced to provide any implementation which they don't require. And this is how you need to implement interface segregation principle. Let us understand this with one example, right? Suppose I want to provide a I want to develop one class for printing, right? So for that purpose, initially, this is my initial development, and you can see this is my interface, and inside this interface, I have declared 4 methods. Give me one minute, guys. Okay, so you can see inside this interface, I have declared 4 methods, 4 services, you can say: print, scan, fax, print, duplex, right? And these services, and for this iPrinter task interface, I am creating 2 different printer. One is SP LaserJet printer, and another one is liquid inkjet printer. And this SP LaserJet printer required all the printer services. So he inherited from this iPrinter task and provide implementation to all these methods. So you can see, and this liquid inkjet printer, he only required the print and scan services. So he is providing implementation to print and scan services, but as it is inherited from this interface, it is mandatory to provide implementation to the fax and print duplex method. So in that case, how it is implementing, it is implementing these two methods by throwing some kind of not implemented exception, right? Even though these two methods are not required, without providing any kind of implementation, we cannot make the inheritance relationship, and this is violating the interface segregation principle. Let us understand this with an example. Okay, let me create a new project with the name select principal underscore ISP. So if each new, not here, we need to add to this existing solution. Add new item, create a console application, provide the name as select principal this. Create a first create a class file with the name iprintertask.cs. Task. Okay, let me make this a startup project. Add class file iprintertask.cs. Within this task, let me copy paste this code. So whatever I'm showing in the UI, that is what. So this is the interface having 4 abstract methods, right? Next, I need to create a class file SP LaserJet printer, and this class is going to implement all the interface methods, right? It required all the printer services, so he is implementing all the methods, right? So let me copy paste the code and print it here. Here you can see it is implementing iPrinter task and providing implementation for print, scan, fax, and the print duplex methods, right? Next, I need to create this class liquid inkjet printer, right? And this printer is only required the print and the scan services. But as the interface contain 4 methods, it is not possible to provide only the print and the scan services. But also we need to provide the implementation for rest of the method, which is not required by this class. This class does not want to provide implementation for this fax and print duplex class, but without providing implementation, inheritance will not be possible, right? So because of this, as we are getting error, so sometimes some developers, what they done, they just provide this through new not implemented exception. By default, this is also going to be implemented, right? So if you remove this thing, so what people are generally does, so they provide the implementation and they are getting this error. So what they are going to implement interface. So you can see this interface, these two method not implemented exception, and this is the not implemented exception method are also provided by the Visual Studio Intelligence, right? So we are providing implementation to this thing. So this is the BATI. So why we are facing this problem? Because we are putting all the interface services within a single interface, right? So this is violating our interface segregation principle. Interface segregation principle saying that if the client does not want to provide implementation, then he should not provide implementation. We should not force the client to provide implementation. In this case, this iPrinter task, the way we have designed the iPrinter task, it is forcing this liquid inkjet printer class to provide implementation for these two methods. This is against the solid principle, right? According to SOLI interface segregation, this should not be the case. We should not force this class to provide implementation to these two methods. How we can overcome this problem? We can overcome this problem by using interface segregation principle. So what we need to do, instead of creating a part interface, we can create multiple small interface, and each interface serving some purpose. See, print and scan, for printing and scan, I am using this interface. For fax, I am using iFax task interface, and for print duplex, I am using iPrint duplex task interface. Now, what I am doing, instead of creating one fat interface, I have divided that big interface into small 3 interfaces, right? And once you have divided the small interfaces, right, then As per your requirement, the class needs to implement. As per our requirement, SP Ledger printer class wants all the printing services, all the services like print, scan, fax, print, duplex. Then that then class needs to implement all these three interfaces like this. And this liquid inkjet printer doesn't want to provide implementation for fax and the print duplex. He only needs the print and scan services, where this print and scan services are defined inside this iPrinter task. So that class needs to implement this iPrinter task services. With these changes, now this class is not forcing. Now this class is not providing implementation to the methods which are not required by this class. So this is how we need to design. So let me first change the iPrinter task interface. Right. So we are going to change this one. So then iFax task. So this one required all the services. So let me inherit it from iFax tasks, and another one is iPrint duplex, right? So you can see this is fine. Now the liquid inkjet printer, it is only required these two services. Now you can simply remove these two, right? Now it is fine. Now we are not forcing the class to provide implementation for the methods which they do not need. So this is how you need to provide this is how you need to implement interface segregation principle. Now, if you create an instance of the respective class, then you can see using SP Ledger printer class, I can call all the four methods, but using this class, I can only call these two methods, right? Now run the application and you will see the output as expected. Any question from anyone related to this one? This is very simple. Just we are splitting that interface into multiple small interface as per our requirement. Clear, guys?
Yes, clear.
Yes, sir.
Any question from anyone?
Sir, one doubt.
Yeah.
So, is it like um, can we do the same thing by replacing the interface with the abstract classes?
See,
No.
Like,
no. Why I'm saying? Because if you are creating multiple abstract classes, then this is not possible. You cannot inherit one class from multiple abstract classes. Multiple inheritance is only possible using interface, but not using abstract classes, right?
but
So, yeah.
yeah, our problem in this case was we should not supposed to implement the methods which are not required for us. But in abstract class, we can achieve that. No, like we can only implement what we require. We can leave what we don't require.
See, in abstract class, you will provide the implementation, right?
Yes, like
Okay.
if
But
the
that implementation is going to be different from printer to printer. In SP Ledger printer, this printer implementation is going to be different than this implementation. How you can achieve that? See, I'm providing this. I'm just changing the implementation. Right? I'm changing the implementation. How you will make sure that? How you will make sure these changes? Is it possible?
okay, if it is completely different, then it is
Obviously,
not
if it
possible.
is not a different, then why I'm going to implement that in each individual classes,
Okay,
right?
got
If
it.
only specific to this class, then I can only provide implementation here. Why I'm going to declare that inside the interface? Understood? We
Okay.
are having different printer, right? So, so for that purpose, I'm designing the classes like this. Now, clear?
Yeah, so the main motto of this principle is that to divide the big fat interface into the smaller interfaces so that we can, if we require all of the functionality also, we can use it through multiple inheritance.
Yeah. So
That's the motto of this.
the main motto of this principle is that no child class should be forced to provide implementation to any method of the interface they don't require.
Okay, okay, got it.
Clear?
Yeah.
Okay. So the last principle that what we are going to discuss is dependency inversion principle. This is very interesting and this is very important because if you are working with the real-time application, definitely you are going to use this inversion principle. Okay, and in this principle also we need to understand many things, right? Let us first understand the definition. What this principle says that high level model or classes should not depend on low level model or classes. Both should depend on abstraction. So basically this the definition, this principle having two parts. First part saying high level model or classes should not depend on low level model or classes. Both should depend on abstraction. Second definition, second part saying that abstraction should not depend on details. Details should depend upon abstraction, right? So we'll try to understand this with some, we'll try to understand this, right? The most important point that you need to remember while developing real-time application is always try to make the high-level model and low-level model as loosely coupled as possible. So basically, in this case, first of all, we need to understand what is tightly coupled and what is loosely coupled, what is high-level model, what are low-level model, what are abstraction, what are details. These things, once we understand, then we can easily understand this definition, and we can also understand this, what I can say, principle, right? So if you are developing one application using tight coupling, right? When a class knows the design and implementation of another class, it raises the risk that if we do any changes to one class, we'll break the other class. So we must keep this high level and low level model or classes loosely coupled as much as possible. To do that, we need to make both of them dependent or abstraction instead of knowing each other. If this statement is not clear at the moment, don't worry, we'll try to understand this with an example, right? Let us understand this with an example. So first, what we'll do, we'll see one example, a dependency inversion principle. Without following the, we'll see one example without following the dependency inversion principle, then we'll identify what are the problems if we are not following the dependency inversion principle. And then again, we will write the same example by following the dependency inversion principle so that you can easily understand the concept. Okay, so let us first create one project with this name. New project, providing the name as this solid design principle and making this project as the startup class, right? So let us create a class called employee.cs. First let me create the project and then I will explain you the code and the architecture, right? So employee.class file. So this is going to be my model class, and this class is going to hold the employee data, right? So this is my model class, and this class is going to hold the employee data. It's a very simple class, you can see, right? Now I'm creating another class file is employee data access logic, right? So this employee data access logic is basically going to contain the logic, right, which is going to interact with the database, right? So which is going to interact with the database and it will going to return the data, right? So basically employee data access logic class will basically interact with the database. But for now, here I'm having only one method, right? So you can have any number of methods. So you can have void add employee, right? If you require, right? Void add employee like this, right? So void delete employee, right? So you can create any number of method as per your requirement. Delete employee, so any method, but for simplicity I'm just using this one method, get employee details by ID. So in real-time application you will get the employee information from the database, right? But for simplicity here I have hard-coded the data because our main motto is not edu.net or entity framework. We are not learning here edu.net and entity framework to interact with the database, right? Our main objective is to learn and understand the principle, how the solid principle is going to work. We are not going to focus on the edu.net or entity framework, but we have already discussed those things in detail. right? For now, if you are having some ADO.NET concept, you can write the code here, which will return the data from the database. If you are using entity framework, right, then you can create a context class and get the data from the database. So those logic will be go here. But for now, I'm just creating one hard-coded employee and I'm returning that employee. So basically, this is my data access logic, and this class will return, right, this class, and this get employee details method will going to return the employee information based on the ID. So this is my data access logic. And this is data access factory class. Let me create another class, right? See, this data access factory class, basically what is going to do, see, if you want to call this method, then what you need? You need to create an instance of this class, and that instance, I'm not allowing the user to create an instance of this class directly. Rather, I'm going to create a class, and that class is going to return an instance of employee data access logic. So what I name this class as employee data access factory, right? So if you go and check this one, so this is my data access factory. So basically, okay, let me remove all the existing classes which are not required for this program, right? So you can see this is employee class, this employee class ID name, department and salary, employee logic class, returning that employee information. You can see ID name, department and salary. Any other method you require, you can create here, because all these methods are related to this employee, right? And then if I want to call this method, I need to create an instance of this class, right? Employee data access logic, and that instance I'm creating here, employee data access logic. And here I'm creating one method, and that method is going to return me get employee data access object, and I'm just returning that employee data access logic, right? And the next one, what I'm going to do, and here you can see this is a static method. You just need to call data access factory dot get employee data access object. This will return an instance of this class, and using that instance, you can call this method, right? The next one is employee business logic, right? Now, employee business logic. Employee business logic, and this class will contain the business logic of the application, right? Business logic means once you fetch the data, right, what is the ID, which employee data you want to fetch. Once you fetch the employee data, do you want to do some kind of validation, you want to provide some kind of calculations, right? Any business logic you want to implement, that you need to implement here. But for now, I'm not providing any logic to this method, right? I'm just simply returning the data. And here you can see employee data access logic class variable I'm created, right? And I'm initializing that variable here, right, within the constructor. And if you remember what this method is going to return, this method is going to return employee data access logic instance. And that instance I'm storing here. And then using that instance, right, that employee data access logic instance, I can call this get employee details method by passing the ID parameter. And that ID parameter is going to return me the data. And that is what I can now what I can say return. Right now, if we go to the program class and just create an instance of employee business logic, employee business logic equals to new employee business logic, right? Then you can create a variable of employee emp equals to what I can say, this employee business logic having one method. What is the method? That method is get employee details. I just need to call this method get employee details by passing the employee ID. And that method is going to return me the employee information, right? And then I can write console.write line emp dot it emp dot name emp dot what I can say department and emp dot salary. So these are the information I need to print. Why I'm getting this error? Into string. Okay, so let me do one thing. Put this inside this dollar. Okay, and put everything inside the bracket. Employee ID, employee name, employee department and employee salary. And to see the output, what I'm writing, I'm just writing console.readline. Read queue. Okay, that's it. Now, if you run the application, you will get the data as expected. See, whatever data I want written, that what I'm written. So in this case, what will happen? We are creating employee business logic class, calling the get employee details method. It will go to the see, while I'm creating the employee business logic, the employee business logic class constructor is going to be executed. Once this constructor is executed, what you will do, he will initialize this variable, and what value will store, it will call this get employee data access object method. And what this method is returning, it is returning an instance of employee data access object. So that object will be stored here. And then what I'm doing, and then I'm calling the get employee details method by passing the value 100. So in this case, it will call the employee business logic get employee details method, and this employee data access logic inside this method, we are calling the get employee details method of the data access logic. And if you go to the definition, here it is returning that employee, and that employee data will be come to where my employee business logic, and that employee information I'm returning from this method, and that data will be stored here, and then I'm printing the logic. Any issue with this example? Anybody having any doubt related to this example? Then I will explain you the inversion dependency inversion. Any question to this example? Anybody not understanding any line of code?
So, sir, why can't you just do the instantiation of the get employee directly instead of going through all those processes?
Yes, there is some reason. So in this case, you might be understanding. See, if you are developing one real-time application, then you are having some presentation layer which will interact with your business layer. Business layer will interact with your database layer, and database layer will interact with your database. Yes or no?
Yes.
So in this case, this is my presentation layer. This program, it is presenting the data. This is my presentation layer. Presentation layer interacting with which layer? Business layer. So you can see I'm creating the employee business logic class and calling the get employee method. So employee business logic, it is nothing but your business layer. So business layer interacting with which layer? Data access layer, DAL, data access layer. So in this case, this employee get details method, you can see it is defining inside the employee data access logic layer, right? And this layer will interact with the database. So this is the 3-tier architecture, and that is the reason why I have implemented like this. Clear? And if you might have one question, that is fine. So in the employee business logic layer, why you are creating like this? Why you are initializing through the constructor? You can directly create an instance like this, right? You can create an instance like this, right? So you can directly create an instance like this, and you can call that method. Why you are creating it as a variable? Why you are initializing that is through the constructor? See, in this case, you are having only one method, right? It might be possible that you are having some get employee. Okay, let me change these things. Okay, void. It might be possible that you are having some add employee method, right? It might be possible that you are having the delete employee method, right? Delete employee method. So in that case, if I'm going to write the same logic, right, this object creation logic, then in each and every method, I need to write the same thing, right? Here I need to copy this thing. Here I need to copy the same thing. Here also I need to repeat the same thing. Instead of repeating this thing again and again in each and every method, what I have done so far is I have created a variable of that type, and then I'm initializing that variable within this method. Now you might be have one question. So if you are initializing, then why not you initialize that directly? Here, why you can't initialize the method directly like this? Why you are creating this data access factory dot get employee data access object? There is a reason for this. For now, you can use like this, right? For now, you can use like this. Now, for simplicity, you can also use like this. Now, if you run the application, you will not get any error, right? You will not get any error. That is fine. For this example, it is working fine. But if I'm writing the logic like this, then there is a issue. What is the issue? Issue is, first of all, you understand what this example is all about?
Yes.
Right? So next, okay, so for simplicity purpose, let me remove all the unnecessary code, which will make application very, I mean, very ugly. Okay, not ugly, but not required. Then why should we put those things, right? So there is no difference. If you use this approach or this approach, there is no difference. But there is a difference if I am going with this database access factory method. That is what I'm going to discuss next. Now let us compare our example with the dependency inversion principle. Once we compare, then we will understand what is the problem, and then we will understand how we can overcome this problem. So as for dependency inversion principle, what it's saying, a high level model should not depend on a low level model. Both should depend on the abstraction, right? A high level model should not depend on low level model. Both should depend on abstraction. So first of all, we need to figure out which one is a high level model in our class and which one is low level model in our class, right? So without understanding the high level model and the low level model in our class, we cannot understand this principle. So if you are developing any application, then anytime, right? If you are developing any kind of application, if you are communicating between one class to another class, means there is a high level model and there is a low level model. We need to understand which one is the high level model and which one is the low level model. See, a high level model is a model that always depends on other model. So a high level model is a model which always depends on other model, right? So in our example, right? So in our example, in order to get the data from the database, this employee business logic class will depend on employee data access logic class or not. Without employee data access logic class, can we get the data from the database? Guys,
No.
that means here employee business logic class is depending on the employee data access logic class. So employee business logic class is going to be my high level model. And this employee business logic class is depending upon the data access logic class. So data access logic class is going to be my low level model. First of all, this point is clear. Which one is high level model and which one is low level model? A high level model is always depend on the low level model. So in our example, employee business logic class, as it is depending upon the data access logic class, so employee business logic class is going to be my high level model and employee data access class is going to be my low level model. Clear? Or still anybody having any question? Guys?
It's clear.
Okay. So what is that definition saying? A high level model should not depend on low level model. Both should depend on abstraction. So in this case, this high level model is depend on this model or not. If I change this class name from employee data access logic 1 to logic 2, do you think that this code is going to work?
No, it's dependent.
It is not going to work because this class is completely dependent on this one. And as per the definition, both should depend on abstraction. High level model should not depend on low level model. So in this case, this is my employee business logic class. This class should not be dependent on this class, right? So if there is a dependency, means there is a tight coupling. So in this case, employee business logic and employee data access logic class are tightly coupled. Tightly coupled means if I'm doing any changes here, then I also need to do the changes here, right? This should not be the case. High level model and low level model should not depend on right? High-level model should not depend on low-level model. Both should depend on abstraction, right? This point is clear. That means the way we have implemented our class logic, the way we implemented the logic, the first part of the principle, it is not following. Clear? Because in this case, it is completely depending on this one. So as per the rules, high-level model should not depend on low-level model. But in the way we have implemented the logic, the high-level model is completely depending. The high-level model is completely depending upon the data access logic, which is our low-level model in our example. This is the first rule, and which is not followed by this example. What he is saying, both should depend on abstraction. So what do we mean by abstraction? Okay, what do we mean by abstraction? Can anybody tell me?
Like it is the process of hiding the essential details, showing only essential.
Okay, yes. So abstraction means non-concrete. Technically, if you are speaking, right, abstraction means non-concrete. Non-concrete means for which we should not able to create an instance. I'm not going with the theoretical definition, because all those things we have already discussed. I'm just going to explaining the point-to-point things, right? Abstraction means which is non-concrete. Non-concrete means for which we should not be able to create an instance, right? And for that purpose, we are having two things. One is interface and another one is abstract class. If we are creating an interface, then we cannot create an instance of that interface. Even though if we are creating an abstract class, then we cannot create an instance of that class. So in simple word, we can say that abstraction means something which is non-concrete. So abstraction in programming means we need to create either an interface, right, or an abstract class which is non-concrete, so that we cannot create an instance of it. In our example, employee business logic and employee data access logic, right, are concrete classes, which means we can create object of them. That means we are not following the second rule of the that means we are not following the second rule of the inversion principle. So what is the second rule of inversion principle saying? The second rule of inversion principle saying abstraction should not depend on details. Details should depend on abstraction. That means if you are implementing independence inversion principle, then you should have abstraction, and abstraction should not depend on details. Details should depend on abstraction, right? How? Let us try to understand, right? As per the dependency inversion principle, employee business logic, which is in our case the high level model, right, should not depend upon the concrete employee data access logic, which is the low level model, right? Both should depend on abstraction, means both classes should depend on either an interface or an abstract class, right? So now the way we have implemented the logic, both are interacting with each other directly, meaning they are creating a tight coupling nature between these two classes. So instead of making the high level classes depend on the low level classes, so what we need to do, we need to make sure that both the classes are inherited from the interface or inherited from the abstract class. Okay, let us try to implement this step by step. So first of all, we need to identify if both the classes are going to dependent on the interface, then that interface is going to contain what information, what should be there inside that interface or abstract class. As you can see in our example, employee business logic uses the get employee details method of the, okay, so let me show you this thing. So in this case, employee business logic uses the get employee details method of the employee data access logic. So employee data access logic having this method. So whatever method you are having inside this employee data access logic, those method declaration should be there inside the interface, right? Whatever data access logic method you have implemented inside your low level model, those method declaration should be put inside the abstract class or inside the interface. If you are working with the interface, that is fine. If you are working with the abstract class, that is fine. The point that you need to remember, we need to create one, we should not allow that class to be instantiated. And we know if we are working with abstract class, then also we cannot create an instance. And if we are working with interface, then also we cannot create an instance. So let me do one thing. Okay, let me create a class. I employ data access logic, right? Okay, within this class, let me create an interface, right? So I employ data access logic.cs. This is my interface. And within that interface, what I need to do, I need to provide the implementation, right? So employee get employee details, any other employee related method declaration you want, you can provide here. Now, this is my interface. Now, once I declare this interface, right, let me go to the employee data access. Other two methods are also there. Let me declare those two methods here also, right? So only the declaration. Okay, let me remove the implementation. And in interface, by default methods are public, so no need to declare them as public again. So this is my interface. This interface having how many methods? 3 methods. Right now, what I need to do, I need to provide implementation. I need the employee data access logic class needs to provide implementation to this method, right? Now, what changes I have done? I have created one interface, and that interface is implemented by this employee data access logic class, right? This is the first change that I need to do. What is the second change that I need to do? Now, in data access factory class, I need to return an instance of employee data access logic, but I don't want that instance to be created, right, as employee data access. So in this case, okay, from here, which one is the parent class? Which one is the child class? Guys, I employee data access logic is the parent, or I employee data access logic is the child?
It's a parent one.
Okay, so can I return an instance of employee data access logic through this type?
Yes.
So that means I am going to returning an instance of employee data access logic, but through I employee data access logic. This is the second change that we need to do. Now, the second change, so there is no difference if we, because in this case, this is the object, that is what I'm returning, and that object I can store inside this parent reference variable. There is no issue because it is the rule of inheritance. A parent class reference variable can hold the child object reference. So this is the second change that we need to do. And what is the third change that you need to do? Now, instead of employee data access logic, what I'm using, I employee data access logic, right? And I employee data access logic, and here I'm removing this statement and I'm removing these things. Now, can you see employee data access logic concrete class inside this employee business logic class?
No.
No, right? So this employee business logic class is depending upon which class? I employee data access logic. Yes or no?
Yes.
And this employee data access logic class is also depending upon I employee data access logic class or not?
Yes.
Yes, that means both the high level model and low level model are depending upon abstraction or not? Abstraction in the sense inheritance or not?
Yes.
So
Yes,
that is
sir.
the definition of first thing is clear. A high level model should not depend on low level model. Now, the high level model employee business logic is not depending upon employee data access logic, because in employee business logic, we have never written that employee data access logic class anymore. And both should depend on abstraction. And now both are depending upon the abstractions. Clear? The second part saying abstraction should not depend on details. Right now, you can see in this employee data access logic, this is my abstraction. Abstraction not depend on the details. Detailed depend on abstraction, right? If you are using this, if you are inheriting from this class, then you have to provide implementation, right? So now, if you want to provide another implementation for this class, right, then you just need to write the logic 1 to logic 2. That's it. And here in the data access factory class, just change this logic to 2. And once you do these changes, do you need to do any kind of changes in this class?
No.
No. That means now you can do unit testing very easily. This is pointing to your database, right? So this is pointing to some your domain database or some unit testing database, right? Whatever changes you can do this. So now it is completely depend on you. Now both the classes are not depending upon each other, right? They are depending upon abstraction, and abstraction should not depend on details, and details should depend on abstraction, right? So in this case, this employee business logic class depend on the abstraction, and this class is depend on the abstraction. But abstraction doesn't know who are the child. I don't care. You can create one child, you can create two child classes, doesn't matter. So this is how you need to implement what you can say dependency inversion principle. Now run the application, you will get the output. So you will see runner 2 CAC and the information what we have provided. Runner 2 CAC and this thing. Now, if you want to use currently, let's see, currently you are using the DOMI data. Now you want to actually connect. Now you actually want to connect to the actual database. So just change this to logic. Now run the application, and you will see that Pranaya and IT. Right? That means there is only changes in this factory class. This factory class will decide which class to be instantiated, and this information up, and this employee class doesn't know about that information, right? Whether you use employee business logic or logic 2, that can be stored inside this employee data access logic interface. Clear, guys?
Yes, sir, clear.
And this is how your code is loosely coupled. Loosely coupled means there is no dependency between your employee business logic and the data access logic. You can do changes to data access logic and it will not impact your employee business logic, because employee business logic doesn't know what is the class name of the what is the class name of the low level model. I'm just using one abstraction, and that abstraction abstract the information of this employee data access logic. Clear, guys? That's it. Any question from anyone? Any question from anyone?
No questions, sir.
Okay. So I will upload this video on my YouTube channel for your reference, right? And I will share the document, whatever document I'm showing in the presentation. I will share this document to you guys all. And in the next Sunday, we are going to discuss AutoMapper, right? AutoMapper, and then from Monday onwards, if LinQ completed, then we will start the design patterns, right? In the next Sunday, we are going to discuss what I can say AutoMapper, and from next Monday, not this Monday, from the next Monday, most probably we are going to start a design patterns, right? That's it for today. Thank you guys for your precious time.
Thank you so much.
Thank you, sir.
Thank you, sir.
Thank you, sir.